Well, hello, everyone. Good morning, good afternoon, and good evening. Wherever you're watching us, whether it's on YouTube or Twitch, thanks for coming to our second episode of the live coding sessions with Solace. Today's episode, we'll be talking more about Solace native APIs. What are they, how we use them, and what are the different things we can interact and do with the Solace native APIs. We have two guest speakers for today. We have Aaron and Tom from Solace, and they'll be joining us today to chat more about the Solace native APIs. I just want to remind anyone who's watching us on YouTube and Twitch, feel free to ask us any question on the chat, the live stream chat. We will see them as soon as you type your question. So that would be great. Whether it's a question or a shout out or you want to chat with us, as soon as you put it on the chats on YouTube and Twitch, we will see it. We could even highlight your question and your shout out on the stream live. To anyone who's watching us as well, I want to remind you all for a couple of housekeeping things we are doing. So we have a poll that we would like you to fill in. So feel free to pull up your phone, scan that QR code. It's a 4 questions poll that we'll talk about a bit on where you found us and a little bit about the Solace native APIs. If you don't want to scan the QR code, there's the bit.ly link at the bottom below. So you could just type that into your browser. It's 4 questions, so feel free to answer those questions. So in the meantime, as you're answering these questions, I would like to introduce Tom, who will be talking about a little bit about the Solace native APIs. So, Tom, how's it going?
Hey, Tamimi, how are you?
I am doing well. I'm doing well. It's good to have you today. Thanks for joining us.
Excited to be here. We've got some good stuff coming up.
Fantastic. Yeah, that's great. Hey, I like your headphones.
Yes. These are the kind of headphones that a 10-year-old really likes. Look, they've got lights on them and everything. Yeah.
Nice.
Yeah, so there's one advantage with these headphones and one disadvantage. The one advantage is they're so big and clunky, you can't see just how long it's been since I've had a haircut, so that's good. Disadvantage is, well, you can see, right?
Yeah.
But the audio quality is good. That's why I've got them on.
That's actually pretty good audio quality. No, I like them. Are they new? Did you recently get them, or you had them for a while and you just like?
No, they're actually my son's gaming headphones. They're normally plugged into an Xbox. So I've kicked him outside and said, go and play in the nice weather.
Okay, no, that's great. Thanks. Where are you joining us? Where are you located right now?
So I'm actually in London. I'm in central London. I'm in Solace's London office. That's where I'm based. Obviously, a lot of traveling around the world kind of thing. But yep, based in London. Beautiful weather here at the moment, so that's good.
Cool. Yeah. I forgot to mention that I'm based in Ottawa. It's pretty warm and toasty right now, but usually it's very cold throughout the year, as you would know. But I'm glad it's warm and toasty right now, which is great. Cool. Let's get into the meat of this session. So we're going to be discussing more about the Solace native APIs, and would like kind of to get more your input on it. And then I know you said you have some things planned to kind of walk us through a live coding session, basically, where we discuss we see a couple of APIs, and then you could talk more details about the different Solace APIs. Before we get started, I also want to introduce Aaron from Solace as well. So we have Aaron on the call. Aaron, how's it going, man?
Am I here?
Good.
Hi, everybody. Yeah. Hey, guys. It's good to be here. I'm really zoomed in. I'm going to sit back further.
You are zoomed in.
All right. Hello. Good evening. Hello from Singapore. It's been raining here for the last week, pretty much nonstop. So I'm jealous of your warmer, lovely summer weather over there.
Oh man, for 1 week, give us a break. Come on.
Yeah, well, it's Singapore. It rains a lot, but it's been raining a lot. So yeah, looking forward to a break from it.
Cool, Greg. Thanks for joining us, Aaron. Yeah, you're here.
Am I centered?
Today, and then pretty excited to kind of talk about the Solace APIs, and also answer questions from anyone who's watching us live on Twitter and on Twitch and YouTube. No Twitter live streaming. Just a quick reminder to anyone who's watching us, these are the live coding events. We have two types of events. We have a live coding events and workshop events. And we will be posting these events on our events page, as you can see on solace.com/events. You can go there to either register or add to calendar the next upcoming events. So without further ado, I'm going to go ahead and start, and I'll ask questions to both of you, Tom and Aaron. Why would anyone consider using native Solace APIs? Like, why should I go if I want to build an event-driven architecture and I want to use any messaging protocol, or I want to implement any messaging architecture? Why shall I go for a Solace native API over other APIs in general?
Yeah, that's a good question, and it's something that needs a little bit of thought, right? So one of the advantages of the Solace platform is that we support these open APIs, so things like MQTT, REST, MQP, those kinds of things. And what's great about those open APIs, of course, is interoperability. Right. One of the things we pride ourselves on at Solace is that, you know, we really do make the make the best event broker, and we want to kind of show you that. So if you want to swap us out for another technology and it happens that technology is best, well, that keeps us on our game. It keeps us producing the best event broker. And so you've got that interoperability aspect there, and that's potentially why you might want to use open APIs. It stops you getting locked in. That's one real advantage of them. There are other advantages too, like you know, you might want to use open source libraries. Now that's great, but there are, as usual with some upsides like that, there are some downsides. One of the first downsides is that maybe you don't get the full features and benefits of the Solace platform, right? Maybe some of the features, some of the funky things you can do, especially with kind of making that whole microservices coding experience a lot easier, you might not get out of the box with an open API. You might be able to emulate it, but wouldn't it be nice if it came out of the box? So I'll give you an example of that. MQTT, certainly in the 3.1 incarnation, doesn't have a request reply pattern. It's quite a common pattern that you might want to use when, say, you're building an event-driven architecture. Generally, you just spit out an event, and you're talking about deferred execution and things like that. But you might need to get an immediate response in some cases, and you can't do that very easily with MQTT 3.1. Turns out MQTT 5.0, which is, I believe, is currently being kind of ratified. That does have it. That's one of the feature gaps that it's dealt with, but you don't get it at the moment with MQTT. So if you need that stuff and you need a feature and it's not in your open API, you might have to start thinking about a native API to do that, because obviously the native APIs support all of the Solace features.
Right.
There's another advantage to the native APIs too. Well, I don't know. It's a trade-off. You might want to use open APIs because they're, you know, supported by the open community. That may be the way you want to go. If you do go with our native APIs, well, if you like that one throat to choke kind of argument, I want to get all my support from one place. Perhaps you might feel more comfortable with that. That's another way of going, another way of thinking about it. There's a last aspect too. It's one I don't generally talk about, but you might want to consider it. And that's obviously because we're supporting the native APIs, we're writing the native APIs, we can guarantee that you'll get the best performance with them. And there is one specific example of that we can talk about. If you talk about JMS 1.1, it doesn't apply to JMS 2, by the way. Okay. JMS 1.1, it's interesting this. I read into the spec. And when you're sending persistent or guaranteed messages, so these are events that you want to store somewhere on the broker so that you can be sure you can get them later. If you use JMS 1.1 to do that, there's an interesting facet of the spec that's not explicit in there, but it's implicit. And it basically means when you're sending a persistent message in JMS terminology, guaranteed in Solace terminology, when you're sending a message like that, you have to wait for the broker to tell you that it's got it. Well, what's wrong with that? Well, when you start looking at the native APIs, you realize that actually that kind of synchronous blocking behavior puts a bit of dampener on performance. And there's some tricks and things you can do in JMS.
Oh, interesting. Yeah.
You don't have those problems in the native APIs. Right.
Right.
So it's a trade-off.
Right.
It's to be frank, it's highly unlikely that you're going to go at the start of a project and think, there's a technical reason I'm going to do this. It's unlikely. It's possible, but it's unlikely.
Right.
It's more of an overall feeling about, what do I think about support models? What do I think about guaranteed compatibility? What do I think about which particular advanced features I may want to use?
Right.
And trading them off against things like open APIs and all the funkiness around open APIs. We, by the way, we love both. One of the features of the Solace platform is you can combine the two. You can just pick and choose, right? You can have your native API spitting events into, say, an MQTT app on your phone.
Right. And you can have polyglot architecture where you can have
absolutely.
Yeah.
Interesting. That's what I was going to say. You don't have to pick and choose within the same architecture, within the same app. You can have native applications in the back end, your core, your client-facing stuff.
Right.
Internet-facing can be, MQTT, open source. So and mix and match, right? So you choose kind of the best for either the performance or the features, or the the openness quality of it, and just pick and choose, and you're not locked into one or the other, right? So that's
right.
Cool features about the broker doing that kind of translation interop.
Yeah, one of the funky things about that, of course, is you typically if you're deploying an event mesh across your enterprise, often you might have different projects, different lines of business with different requirements. I mean, Aaron, you mentioned the stuff about internet facing. Maybe you've got a requirement there that you need open standard APIs, right? Because there you've got that kind of community investment in exposing security flaws. That may be your rationale behind your security team. Who knows, right? But then maybe you've got a project that's kind of super focused on, I don't know, performance as an example. You can mix and match the two across the enterprise and across your whole event mesh, no matter whether that's kind of distributed across time zones and geographies, or it could be distributed between on-premise and on the cloud. You've got that capability of mixing and matching, right? And that's one of the reasons why we put this together. We wanted to kind of show that, yeah, you can use open APIs. That's great. There's lots of material out there. But what about these native APIs? Well, let's learn a little bit about those too.
Interesting. Yeah. You bring up a good point. You had an example about, if you want to implement some sort of like an event mesh and you have different applications, including like, legacy architectures or IoT devices. Do you have a particular, for example, like example or use case where there's a mix of applications that are using native APIs and using non-native APIs, like for example MQTT or MQP, and all harmoniously communicating and interacting with each other over Solace Broker? What kind of like example or use case do you have for that?
Yeah, I've got loads. One of my favorite is, unfortunately, I can't mention the customer name, but essentially it's kind of a payments provider, kind of credit card operation. And there you mentioned about legacy to me. You've gone all the way from a mainframe application. I love it. Started my career in 95, and I never thought I'd be talking mainframes then, let alone in 2020. But it's true, right? That's the point of this legacy stuff. It hangs around.
Right.
They've got their mainframe application, and they're talking all the way out to mobile devices, right? So they've got WebSockets, they've got iOS, they've got mainframes. They've got IBM MQ. They've got all of this stuff, and it all needs to talk to each other, right? If the mainframe wants to send out a notification to say you spent too much, or you've updated your loyalty profile, that needs to get to the mobile phone. Right. And you could have loads of different layers doing that, right? You could have like a layered architecture with lots of different technologies all trying to glue together. Killer thing about Solace, right? Single architecture, single layer. You're able to talk in with whatever protocol you want. You're able to talk over any environment. So could be all the way up to cloud. It could be into a CDN for your mobile applications as well. So yeah.
Yeah, no, that's an interesting example. Thanks for shining light on this. So I think that's a good overview that you gave us, Tom and Aaron, about kind of like the general overview of Solace APIs. Why would someone use kind of like a native API over a non-native API? And is there communication between non-native APIs and native APIs? So if someone has like a polyglot implementation of their architecture, they still could like harmoniously communicate with each other, which is great. So thanks for this. So I would say let's go ahead and kind of like delve deep into Solace APIs. So in today's session, what kind of APIs are you gonna go over, Tom?
Yeah, so we've got a collection of native APIs across different languages. So we've got C, we've got C#.NET, we've got Node, we've got JavaScript, and yeah, so we've got all these different APIs. In this session today, the examples I'm going to show are mainly C and Java, and there's a couple of reasons for that. C, because it's a bit different, and if you're really worried about the performance side of things, that's maybe where you want to look. And Java, yeah, it's just well, frankly, it's because it's the one I know the most about, right? Simply. But of course, we can, we've got the poll, as you mentioned, where people can fill in their particular language of choice. So we can talk about .NET, for instance, or we could talk about JavaScript as examples.
Right. Okay, perfect. So I am going to go ahead and share your screen, Tom, where we could go over a couple things, and then I will give the floor to Aaron and Tom to kind of like go through the discussions. In the meantime, I want to remind anyone who's joining us right now that I posted a link on the chat, whether you're in Twitch or YouTube, for a poll to fill. This is the poll. You can see it down below. And if you have a mobile phone with you, you could just scan the QR code at the top. Here you go. Aaron is going to scan the QR code and fill that poll. So
why not? I haven't done it yet.
There you go. Fill it up. Yeah, it's only 4 questions. Let us know how fast it takes you, Aaron, to fill it. And as always, audience questions are accepted. So if you have any questions, feel free to ask us right here, and we'll take it from there. All right. So Tom, the floor is yours, and I shared your screen.
Great. Thanks very much, Tamimi. Thanks for a brilliant introduction. So just to highlight something Tamimi said there, this is kind of supposed to be an interactive session. Please do ask questions. What will happen is Aaron will shout across me probably with the questions. So please do ask them. Okay, so one of the first things I want to cover is that in Solace at the moment, as part of our kind of developer outreach program, we are using code labs. And there is actually a code lab for this particular live coding workshop today. It's not the only code lab we've got. Aaron did one last week about event enabling your REST architecture with Solace. Recommend that one. It's really good. And we've got some other ones there. Sorry?
Said thanks. Yeah.
It's all good, right? It's all about self-plugging, right? So we've got some other great ones here. There's some Kubernetes ones that, for instance, I'm going to check out later on. But today we're going to be exploring native APIs. As I've said there, this is about the basics. It's flagged as Java. It isn't. It's Java C. We can talk about other languages if you like. But the key really is to get across the basics. What are the concepts? What are the constructs that you need to understand? And hopefully at the end of that, you'll have a better idea of when you look at, say, the API reference documentation and it starts talking about something like a session, you'll have a better idea of exactly what it's talking about. So that's what I'm aiming for today, to get you used to the API concepts and show you some example code, right? Okay, let's go into the code lab. I've got this introduction here. Thanks to Tamimi, he's introduced a lot of this stuff here. But just to review, we in Solace love this API diagram here, right? It talks about all of our different APIs that we support. We've got our different open standards that we can hook into. Generally, just about any language you might want.
This one doesn't show the languages, eh? It's a simpler version of it, I guess, because there are too many languages now. There's like all these different APIs.
Hang on, let me zoom in. Does that make it clearer? Probably not.
Oh, it's easy. It's easy to read, man. No problem.
Oh, good. Okay, let me minus that a bit. Cool. Okay, so yeah, we've got lots of different languages that you could support. So just a quick thing, what are we talking about when we talk about protocols and languages and stuff? Okay, when we talk about a protocol, we talk about how you put the data on the wire. So if you're talking about MQTT, that's like a framing specification that says, here's what an event should look like. And then you have language bindings for it. I may be teaching you to suck eggs here, but it's always worth going over that. So yeah, so MQTT, you've got the Paho open library there with different language bindings in it. Same for AMQP and Cupid. Mark is probably on this call, will not thank me unless I mention all of our Spring integrations here. So if you're using Spring, you can integrate that with those really easy. Not going to be talking about that today. That's for another time. Some other things. Aaron talked about this REST interface last week. Now, just to make this point, of course, you can mix and match, right? So you can have MQTT running C++, talking to Spring Boot, talking with a REST webhook, for instance. All of this interacting completely natively because there's no translation, there's no plugins, anything like that. It all comes natively with the broker. Super cool. So that gives you that kind of pluggable architecture where you can just insert another listener. One of the use cases that I probably should have mentioned when Tamimi asked about use cases, imagine you've got two native applications talking together and, shock horror, somebody comes along and says, wouldn't it be great if we could suck that into a data lake? Well, that's great, right? Because you can just create a REST consumer, something in Solace we call a REST delivery point. And all of a sudden, you're sending those events off to a webhook. Great stuff, really good. All right, so native API languages. We talked about a couple of the reasons why you might want to go native. It might be because you need a particular feature, especially if you're doing microservices, you've got a polyglot architecture, you want to make your life as easy as possible.
Mark says Spring Cloud Streams for the win, by the way. He appreciates the shout out there.
Good stuff. You see, it's all about the shout outs, right?
Hey, I do want to mention one quick thing there, Tom, before you move on. Like, I've written so many demos, and I've had customers that have used specifically JavaScript front ends using MQTT and our JavaScript API. So depending on the use case, JavaScript on the front end for your mobile browser, connections, and then Java and C applications in the back end using Solace Native. And then to your point, hooking that up to some kind of open source data lake, either using REST or using sometimes using MQTT as well, or JMS. So many of these things are plug and play, and you basically just kind of choose, which protocol does it support or which API does it support. Oh, we support 2 of those. Let's just plug in whatever, and it just works. It's great. It's really great. So.
Yeah,
okay.
It really does make that kind of integration piece of the event-driven puzzle that much easier, right? Give you an example. A colleague of mine, Jamil, wrote a nice little demo where he needed to interact with cloud services. So what he did is he used the REST API and some lambdas or serverless functions called by the REST API to do some interoperability between some cloud functions, some cloud services. Really cool stuff. All right. Tamimi asked about native API languages, and here they all are. So we've got C, we've got Java. One we do have is Java RTO, real time. That's for people who want to use Java but want to use a no garbage collection architecture, typically for lower latency applications. We've got .NET, we've got iOS, we've got JavaScript, we've got Node.js. Quick plug here. We are soon to be releasing our, Aaron, correct me, it's Python rather than Go first, isn't it?
That's correct. Java first, then Python. So
sorry, Java first. You mean? There's a new Java API coming out.
Yeah. Soon, and Python, and Python's next. We've been asked about Python for years. Why don't we have a native Python API? And there are Python APIs for MQTT. There are Python APIs for AMQP, for REST. So there are open standard versions. And some people have taken our C API and wrapped it. And they're like, why isn't this native? Why don't you guys have? So we are finally building a native Python API, which is quite exciting, I think, for a lot of data scientist people. I mean, Python's just everywhere, right? So
yeah, it's kind of your general purpose scripting.
You heard it here first, folks. It's coming. I don't know exactly when. Dates are getting shifted around, but it's not supposed to be too far off. So yeah, pretty excited.
Yep, good stuff. As you mentioned, Aaron, we've got a new Java API coming out. Just tidies up some of the aspects of our Java API, brings in things like Java 8 kind of semantics, that kind of thing, just to make it a bit more...
Much more modern. Much
more. I was going to say modern. Yeah, exactly. Yeah. Yep. So that's coming out soon, within, I think it's the next couple of months. So that's good.
Yep.
Okay. Hopefully that's enough in the way of introductions here.
Yeah, let's get on with it. It should,
okay. What are we going to do? Right. We're going to talk about sample code, documentation. We're going to talk about how to get started with the native APIs. Yep. We're going to talk about connecting to the broker, because that's kind of what we want to do here, right? That's what it's all about. Once we start talking about that, we're going to start to bring in some of these features that you kind of need to know to use the native APIs, right? Now we're getting into the core of it. So things like callbacks. So this reactor pattern, right? We want to react in an asynchronous way, because that gives us a nice symmetry between our asynchronous event-driven architecture. We want that in our code too. We want our code to be asynchronous. And that brings us into this idea of a session. What's a session? It's the way of encapsulating communication with the broker. We're going to talk about session events. And we're going to talk about how we send and receive messages, because that's kind of
important.
What we're after. Yeah. It's kind of
a big piece of it.
It'd be good if we could get to the end of this without sending and receiving anything, right? Everybody would be really happy.
Yeah.
All right, good stuff. So, right. So this code lab is there on codelabs.solace.dev.
The URL was down at the bottom there. If you just want to follow along, feel free. Thanks to Mimi down there. Codelabs. Tom, I don't think you can see the screen that we're sharing. Yeah. Okay. So the URL is down at the bottom there. Check that out, or follow along with Tom. We're going to be going through it together. So.
Yeah, so this is not the kind of thing where you kind of really have to follow along to really get the benefit of it. Hopefully you kind of listen today and maybe take this code lab aside later on and kind of just check you understand everything. This is more about getting the concepts over today, okay? So if you do want to get started with this stuff, there are some prerequisites and assumptions. So you probably want to have your favorite IDE fired up and ready to go. That's not mine there, that's a little joke. But we do need to have a broker, and I've got broker in colons there. So we have some options. We can use Docker. We can use a virtual machine, something like VirtualBox or ESXi. Or you could even use Solace Cloud. So PubSub plus Cloud, right? So we can just run a free developer plan in the cloud. In fact, do you know what? Why don't we get started and start looking at a cloud instance? So I'm just going to swap. Wow, that was quick. Okay, so here I've gone to console.solace.cloud. Aaron, do we have console.solace.cloud?
I can see it. Yep, looks good.
Good stuff. Let me zoom in a little bit.
Oh, you mean a URL? No, but just tell people. That's
it's
there. It is. Thanks to me. Console.solace.cloud. Yep.
So here's what you're presented with when you first log in. You can just sign up. It's free to sign up. No restrictions there. And you can actually sign up for a free developer plan, but you'll be presented with an interface like this. Aaron, when we start talking about topics, remind me to get some event portal stuff in there, because it is so cool. We got to talk about it, right? Okay, so let's talk about our messaging services. So we just click on our menu on the left and up we come. So you can sign up for a developer plan for free. You click this button, you fill it out. I'm not going to do that. But if we just go into our developer plan, there's just a couple of things I want to show you. So here is our developer plan, and we're going to use the connect and manage and try me tabs later. If you are following along, it's probably, and you don't have a developer plan, it's probably worth clicking that plus button right now just to get it started up. It'll take a minute or so just to provision the plan for you. Okay, the alternative, of course, is to use Docker. So Docker's
the easiest, I think. Yeah, for sure.
Yeah, so Docker's dead easy, right? You can do a Docker pull. And I'll just give me a second later on and I'll show you where all the instructions are for Docker. But I'm just going to show you that I've got a Solace PubSub standard latest Docker image running right now that we can connect to. Okay.
How many? So you're exposing all your. I see your ports being exposed there. So this is one thing that I like to kind of point out when people are first learning Docker. Maybe they don't know this right at the beginning. Is your ports are kind of exposed when you create the container. So if you want to expose ports later on, you kind of actually have to remake the container, which is a bit of a pain in the butt. So you want to make sure that you you expose as many ports as you feel you might need, right? It's just a limitation of Docker. It's something that bit me in the butt once when I first started playing with this stuff. So yeah.
Bitten me in the butt, goodness knows how many times. I will cover later, actually. One of the ways you can get Docker started with Solace is you could use a Docker Compose script.
Yeah.
If you want to follow along, there is an edit you need to make to the default Compose Docker Compose script, just so that you can use one of the features we're going to talk about. But it's fairly simple. It's just a matter of uncommenting a single line.
Yeah.
Cool. Okay, so let's have a look back to our code lab. We've got a broker. Yeah, we should talk about authentication. A couple of points there. Obviously, Solace Event Brokers will check you are who you say you are by the easiest way is either nothing, you can just connect, or you've got this thing called basic authentication. Basically, that means we're not using TLS. We support TLS really well. It's brilliant, but don't really have time to go through that today. We're going to focus on the basic authentication here. Yeah, that's good. All right. So, excuse me, where are you going to get your broker from if you want to download it? Well, there is this great thing you can do called solace.com/downloads. Here we go. Hopefully you can see that URL. And look at that.
It's on the screen.
Yeah.
Yeah, it's on the screen there. Yep.
Good, man. Okay. So there's this whole downloads page, and there's a whole load of stuff on here. So you can get your images. You can get your Docker image. You can download it. There's a quick start that you can follow that helps you get started really quickly on Docker. So I'm on Mac. So if I go Docker for Mac, here we go. Here's that download that Docker Compose template I was talking about earlier, one that we need to make a slight edit for. Yeah. So what else do we have? We can download cloud images. We can download virtual machine images. We've got some of our management tools here. Yeah. Enterprise evaluation. I'm going to talk today mainly about PubSub Standard Edition, PubSub Plus Standard Edition, which is, whoops, sorry about that, which is this one here. That's our free-to-use edition. It's completely fully featured. It's not feature crippled at all, apart from one thing, it's got a rate limiter. Okay, so it's rate limited to 10,000 messages a second. That's a lot. That's more than enough for many use cases. But obviously, if you want the full unlocked edition, we're going to ask for some money, and you'll get the enterprise edition there. But apart from that, they're both the same. Because I'm nice, I'm going to deal entirely with the standard edition today.
And Tom, I have a quick question.
Yeah.
The 10,000 messages a second limit, is it the same on the PubSub Cloud and Docker images and like the other images, like the cloud and the software offerings? Okay,
so that's a good question. For the software images, so that's Docker, ESXi, whatever. Yeah, so that 10,000 messages a second limit applies. If you're using, say, a PubSub Plus Cloud Developer instance, there it's down to the limits of the cloud infrastructure. So you might be able to burst to 10,000 messages a second. Highly unlikely. There are a bunch of limits around these. When you go to the Messaging Services tab here, or let's say you create a service, you can see that you can start configuring some of these parameters, right? So you can say how many connections do you want, what network throughput do you want, how much storage do you want, and with this kind of zippy configuration wizard, it'll start telling you what kind of particular class of cloud service you need. Okay. Hopefully that's covered that question. All right, Tamimi, is that good?
Perfect. Yeah, that's fantastic. Thanks for that, Tom.
Great stuff. Okay, good. Right. So we've talked about downloads. There was one other thing I wanted to mention. Oh, yeah, of course. That'd be nice, wouldn't it? We probably want to maybe download our APIs. For something like C, obviously you need to download it because you need the dynamic library, that kind of thing. Probably the same for iOS and .NET. Maybe if you're using something like Java, you can use your dependency management system to do that for you. You can probably use that in C as well. So here's a good place to go. You get release notes, you get a download link. It'll give you an archive file that you can download. Obviously, I've already done that. So yeah, good place to go, solace.com/downloads. You can get Open API and protocol downloads here as well. Oh, look, lots of other funky stuff. If you want to use, we've got these funky Kafka connectors so that you can connect your Kafka cluster directly into your Solace event mesh and share events between the two. We've got Beam for kind of cloud streaming processing applications. Yeah, good one. Now I'm going to deliberately help Aaron to lose a layer of tooth enamel now. In these basic sessions, I'm hoping he's laughing. In these basic sessions, in these basic sessions, we're going to use a kind of an very easy to use graphical application, Try Me, to just see what's going on across our event mesh. Once you start getting into details with the native APIs, you may need something a bit more performant and something with a few more features that kind of teases out more of the details about the events that you've got flowing across your event mesh. That application is called SDK Perf. As the name implies, it's our kind of universal test harness for our event brokers. So it does a couple of things. It does performance testing. So if you need to do any rate testing, SDK Perf is the place to go. It also exercises either all or very nearly all of the API features. Yep. So I'm probably going to drop that there now, just to say that once you do get really going with the native APIs, you should really consider using SDK Perf, as you can use it just as a listener and just to check that what you're sending or receiving from the broker is what you think it is, and it's not a problem with your particular piece of code, right? Yep. That's a really useful debug feature.
It's a super useful tool that any Solace developer and or ops person should have in their pocket, to just listen what's going on across the bus, across the event bus. Yeah, and to your point, yeah, if it's anything more than just kind of Mickey Mouse ping pong type data rates that you can use the Try Me capability for, SDK Perf, and it's free. It's available for most of our different APIs. Great load testing. You want to crank up the rates and see how much can your infrastructure handle. That's the tool to do the job, right? So
yeah,
definitely super useful tool.
Absolutely, thanks, Aaron.
At the very bottom of the downloads page.
Yep. Yeah. Okay. Good. So we've talked about solace.com.downloads. What other resources do we have to help us? We've got docs.solace.com. So that's obviously where all the documentation is, right? So I love docs at a glance. That's where I always go. Don't know about you, Aaron?
I always start there. Yep.
It's got some nice introductory thing, some kind of overview of the platform there. This Try Broker is really quite handy because it's got some lovely getting started stuff. So for instance, I've talked about how do we get the Docker edition. And we've got a walkthrough. We've got videos. We've got some steps here. So here, rather than using Docker Compose, we're using Docker Run.
One click.
Yeah. And what's cool here is Aaron was talking earlier about port mappings, and that's what these -p options are, right? So that's
I actually helped write this particular command here. I was like, we need to add more ports because I got burnt, and I was like, we should have this in our docs. So
yeah. And in fact, actually, Aaron, that's a good one because this one here is what's missing from the Docker Compose template.
Oh yeah.
Yeah, that breaks Try Me.
Oh, that's WebSocket, eh? Yeah.
Yeah. Okay. Yeah. So good. So docs.solace.com, we've got the get started stuff here. So if you prefer to do it this way rather than using my CodeLab as an example, you can do it here. And it'll take you through, and oh, look at that. It'll talk about running the samples, which I'll talk about too. And guess what? Here's our Try Me application here where we're going to kind of send very simple messages to test what we're doing. Yeah. Great. Okay. Great. Yep. Sorry, Aaron, was there something?
No, I didn't. I'm just saying random words, man. Just keep going. You're doing good. You're doing good.
Good stuff. All right. What's the point of going to docs if we don't look at the APIs? Look, there's a whole API session here. So if we go to messaging APIs and protocols, quick point of nomenclature here. Solace native API is sometimes kind of spoken as Solace messaging APIs. It means the same thing. So if we open that up, got some nice introductory material here. So let's have a look. If we want to look at the JavaScript API, it talks about what message patterns do we support? Do we support request reply? Answer, yes. Talks about the features that we expose. And then what you might really like here is we've got some tutorials, which illustrate some of these message exchange patterns. And what's interesting here is a link to the samples that we're going to be looking at today. Deal with that in a minute. But if we kill that one off there, obviously we've got the API reference, right? And kind of part of the idea today is that hopefully after listening here, if I open this up and start talking about session, you'll know what a session is and why it's important and what are all these session events. That's what the kind of thing we're going to talk about today. So hopefully you'll be able to get into the API reference really nice and quickly after today.
Hey, Tom, one thing I want to point out, because it's recently moved, I just want to point people to it. In addition to like the specific, API references and stuff, I head back to the previous tab there, to the docs.
Yep.
And then the section above messaging APIs and protocols says developing applications. Just click on that there. And then the third one, Solace Messaging API Developer.
There we go.
That one, Developer Guide. This used to be the kind of de facto, originally PDF way back when, of all the kind of concepts like sessions and flows and contexts. This is where it is now. I don't know if it will move again, but this is also super, super useful for kind of learning the stuff that Tom is going to be showing us today in the thing. So, yeah, just
great.
Keep this in mind if you need to.
Yeah, I didn't know that had moved there actually. So I remember it being in the PDF. Recently, so. Yeah, great stuff. So for instance, it's going to talk about sessions, for instance, which we're also going to talk about today. Hopefully, by the end of this, you won't need to read the sessions bit. You'll understand all of what's going on in the session. Good stuff. Okay, right. That's docs.solace.com. We've covered the getting started bits. We've talked about the API reference guides and the API guides. So we need more materials, don't we? We need more collateral. Okay, let's talk about Solace.dev. A great resource. Obviously, we here in the developer relations team, we're super proud of this one.
It's our one-stop shop for all things dev, Solace Dev. Yep.
And look how funky it is. Look, we've got stuff moving. I actually really like this bit here. So here you can see some JavaScript code, and it's talking over here to Java code or JMS code. How funky
little
is that?
Snippets, like just to show how easy it is to boot up a consumer or a publisher on either anything to anything, right?
Yeah, exactly. And so hopefully this will act as a kind of reference and you can kind of copy chunks of code. But after this session, sorry?
No, Tamimi put the URL up for us. So yeah.
Cool. Good man. Yeah. Yep. So hopefully after this session, you'll understand when I say topic here, what does that actually mean, right? Because it can confuse people. But once you understand that, hopefully you can just copy these code snippets there. That looks like a familiar diagram, right? We're going to talk about the native APIs today. Quite a nice funky one here is very quick way of getting connected. So that's an important point, right? Because you're using Java, you can use the Java language with all of these different protocols, right? So these protocols have got different language bindings. So for instance, MQP, you could use the Cupid library with their JMS binding there, and you can kind of get started. So we're using the native one. Aaron, help me, I'm confused. I'm a developer. There's nothing here that says native. What do I need to look for?
So we refer to our native protocol as SMF, right? Solace Message Format. So anything that you see with SMF is our, I guess, proprietary protocol, right? It was our original protocol. Like back in the day, these kind of open standards didn't exist in the messaging world. REST, HTTP, the internet was built on that, but the same were not available for wireline kind of protocols and messaging. So we've developed our own, as did a bunch of our competitors and friends. And now that these things have standardized, MQTT, AMQP, it allows more interoperability, as you said kind of early on. Anyway, yep. SMF is what you want to look for.
SMF, that's what you want to look for. Solace messaging format, right? So we click Get Started. It's lovely. It's got, here's how you interact with your dependency management system.
Gradle. Look at that. Gradle, 1 line.
Gradle.
4 lines? Come up, 5 lines.
Oh.
Gradle.
Save that individual character. That's what you want.
Right.
Yeah. So again, copy code. Connect to service. So more code snippets here. And here's a quick point. Here's something I really like. If I go to Solace Cloud and go into my service, and I go to the Connect tab here, again, Solace messaging. That's our native API.
That's right. And this is available in the free version as well. When you sign up for Solace Cloud with the free 50 connection tier, all this looks exact same, right? So.
Yeah, no, that's exactly what I'm actually there at the moment, and I think it's 250 connections now. If I go to get, yeah, I believe so. Yep. So if I go to, let me just repeat that just in case you didn't see it. I've gone the wrong way. Oh no, that's all right. We can just go back in here, so you can tell it's live.
Yeah. And if it's really 250, that's awesome. I was looking at some free MQTT brokers a while ago. They were like as a service, right? It was out in the cloud somewhere as an MQTT. Five connections was their free tier. Like wow. So you can hook up like a few light bulbs to your free system, and that's about it. So
yeah, knock yourself out, kids.
Anyway.
Okay, so connection details. Yeah, so when you start running the samples, you will need these connection details here. Or if you hit Get Started here, again, it's the similar kind of thing, using Gradle or whatever. But look what it's done. It's filled in
code.
Yeah,
yes.
That's really nice. Copy. Lovely. Yeah. We like that. That's good. Yeah. Cool. All right. Wow, we haven't even talked about samples yet. Another quick one to mention is Solace.community.
So many things to remember. Oh my gosh.
Oh man, Solace is so many resources for you.
Check out that scrolling. All right. Yes.
Sometimes you kind of wonder, where do I start? Start anywhere. They'll all link to each other.
Yep.
So this is Solace.community. I would encourage you all to sign up to this if you're using Solace. The idea is it's an open forum, right, where you can talk to other Solace users and where kind of people like Aaron and myself weigh in.
Yeah, we hang out there all the time. That's all we do. Just
That's what we love it. We love it. No, it is good. It is good. It's a way of interacting with people without having any kind of commercial kind of thing in the way, which is good. And it's not just about specific, say, coding questions. It can be anything: architectural, general use patterns. How do I build my application? You might not get a full kind of consultant level of support, but we'll do the very best we can to help you. We've got lots of interesting things here. Topic names on queues, and you can see. We've got somebody asking a question. Aaron's weighed in with some answers, pointed this person to the documentation. And look, and Aaron's done his office hours, which I also encourage you to check out, which is where Aaron's just online. So if you've got any questions, you can ask him.
Hey, Tom, hold on. So we got a question that came in just when we were talking about it, but from Cool Dev Ninja. What is SMF? Well, we kind of did talk about it just recently, but I'll reiterate just in case you just tuned in or you just missed it. It is our native messaging protocol called Solace Message Format. It is the wireline protocol that our native APIs use to the Solace Broker, and brokers use to other brokers when they're building an event mesh to route data between them. It's a wireline protocol similar to MQTT, similar to AMQP, but it's one that Solace built and develops and adds to for our native kind of capabilities. So that's what it is. Solace message format. And if you look for in the as Tom was showing there in the various connection options, If you see SMF as the protocol, that means it's a native Solace API.
Yep. So if you're using the native APIs, you'll be using the Solace native protocol, SMF, as Aaron says.
That's
cool. All right. We haven't even really talked about samples yet. We need to get on. Okay.
Let's get on with the code lab. Yeah, we get. I'm keeping you on track here. It's 10 to 11. Oh,
Got to get going.
Yeah, I was just going to say that so far these are the resources that you put on, which is great. So thanks, Tom, for going over that. I just want to remind anyone who's watching us, we have a pool that you can fill out, so you can see the link,
the QR code
and the QR code. So just get your phone. And yeah, this is it. Get your phone and scan that code to answer the questions. It's a four question poll, so it's pretty easy and very quick. And right now, Tom, after you kind of like went over the resources, I say it'll be a good idea to jump into the code lab and see some actual code. So let's go ahead and get into the code lab.
Yep. We need to talk about the samples. Where'd you get them from? Let's go to Solace samples on GitHub.
I'll be right back. Tamimi.
Yep, Solace samples on GitHub. GitHub.com, Solace samples. Here we go, all of the native samples. So, it's GitHub, right? If you want to get the Java samples, you just go to clone and do a git clone or a SVN checkout or whatever. Quick thing about the structure of the samples. Generally, they follow this basic kind of features here, followed by a features directory there. The point with features is to cover some of the more advanced Solace features. So, for instance, in Java, we talk about message replay. Today, we're going to be dealing with the basic ones. So it's going to be basically topic subscriber and topic publisher. Some of the APIs don't necessarily have this features filled out yet. We're kind of filling them out as we go along. When you go to the tutorials on, say, docs.solace.com, and it talks about basic subscriber, it's going to take you to this particular topic subscriber. Right. Where are we? We've got, what have we done? We've got the broker. We've got our API. You know that Solace samples exists. You can write code. Probably doesn't apply to me, but there we go. You've probably got SDK Perf. You know the tutorials are there and the developer labs and stuff like that. And you know that Solace downloads exists. Excellent. All right. Let's actually get started. Let's talk about how we can connect to our broker. Before I do that, let me talk quickly about some more about the sample structure. We've got two kind of places for the samples. One is in the API code itself. So an excellent example of that is C. I've got this open in, that's probably way too small, isn't it? So let me zoom in.
A little bit small, Tom. Yeah, I'm back, by the way. Snuck up on you here. I can read it. People, yeah, you can read it all right, maybe.
Okay, can I zoom in?
Lean in.
I can with the code, but not with that. So here are the samples that are included as part of the API download, and they are separate to say, here is the Java case. Here's my Solace samples GitHub clone, right? So here's the basic. Then we've got topic subscriber and topic publisher, and we've got the feature code here. That's kind of distinct from the samples that you get with the API, which is kind of more feature samples, more advanced stuff.
That's right. Yeah, the stuff that's on GitHub now. This is going to change. It's actually something that I'm working on, is to help harmonize all the GitHub samples with the stuff that's available in the tarballs that you get on our downloads page. So most people start with the GitHub samples. Those will get you 80% of the way there, and then inside the downloads page, some of those distributions, there's some more feature specific kind of advanced kind of stuff in there. So
yep. Okay, cool. Quick check, Aaron. We have some code. Can we read it?
I can read that. I think it looks all right. Yep. Excellent. I'm happy. Yeah.
All right. So we want to run this code, but not so fast. First of all, we want to make sure that we can connect to the broker and we understand how to validate our connection. So sorry, going to wind you back a bit. What we need to do is get our try me working. Now, I've got Docker working away here. So I'm actually going to connect to my Docker instance. which is on localhost :8080. And I just go there. By the magic of technology, I've got this wonderful thing called PubSub Manager, which is our default kind of management GUI, management and monitoring GUI. Well, not so much management GUI. We do have several management options
and configuration. Yeah.
So we do have several management options. You can use PubSub Manager. We've got an old thick client called SolAdmin, which some people still like to use. You can use the Solace Management API called SEMP, which is Solace Element Management Protocol. Got that right? Hooray. You can use that. What's interesting about SEMP is that PubSub Manager uses it, as does SolAdmin, right? So we're kind of eating our own dog food in that regard. And what's the last one? CLI. CLI.
Yep.
CLI is for, I like to use it, put it that way. Aaron likes to use it.
I love
some of us diehard techies like to use it.
Command line interface, yeah.
Yeah, exactly. So you can use it. We're not going to deal with it today. And that's all I'm going to say about the different management options, because that's not the subject of the conversation today.
So, Tom, quick question here from, again, from our friend Cool Dev Ninja.
I like Cool Dev Ninja.
Yeah. I like questions. So this is, can we access the try me functionality from the cloud? So when you do the broker version, let's also show the cloud version. Let's show both.
That's a good idea.
And I think also kind of like related, let's show the PubSub Manager in the cloud as well, because it doesn't matter whether it's cloud, whether it's software on your local system, it manages it all the same. So let's show those.
Absolutely. Good point. And there's one thing we haven't mentioned. Some of you may be lucky enough to have an appliance that you can connect to. And all of this is available on the appliance too. All you got to do is replace localhost here with your IP address of your appliance. That's the management IP address. It's probably port 80 rather than 8080, and away you go. You'll get the PubSub Manager interface too. All right. Not forgetting the cloud, but just continuing with my local Docker instance. We should very quickly talk about message VPNs. What are they? Bit of company history. Company was founded by kind of networking engineer guys, people from Mitel Networks and Nortel Networks, that kind of thing. And they were, and that's one of the reasons behind our kind of blistering performance, right? Is they're thinking from the network up rather than the application down, and they're thinking multi-CPU, embedded software developers, all that kind of thing. One of the disadvantages is they like this idea of the a VPN, virtual private network, as a kind of slice of something, as a slice of a network.
Separation, yeah.
Yeah. So we have that concept on the broker. Slightly confusing. Message VPN does not refer to the network. It refers to the broker, and it's like a virtual slice of the broker. Okay, it's a separate messaging namespace. So if I were to create a message VPN, I've got one here default. If I were to create another message VPN, not default, all of the messages that are sent to default will not be available in not default. It's a namespace, a virtual slice of the broker.
Yeah.
That's all I want to say on that. Don't want
like
to
a different channel, right? It's a different channel on a TV, right? It's like they're separated, but yeah.
So typically you might have particular applications or lines of business would have their own message VPN.
Or developers, each developer would, or whatever. So
potentially if they're in a developer environment. Yep. Right. We need to do something. Let's do it. Let's do that.
Try me.
Try me. Look at that. Try me down on the left-hand side here. That brings us to this page here. And look at that. We've got a publisher and a subscriber. So if we want to connect to the broker, it's very simple. We hit connect. Fortunately, the PubSub Manager has filled out all the connection details for me. And I'm connected. So if I go to my excuse me, if I go to my cloud instance here, I've got the same thing. Where do I go to try me? It's not down there. It's over here, right? So it's just up there on the tab. Very similar. And I can just hit connect. Hooray, I'm connected. First thing passed. Right. Okay. Just because the API has told me I'm connected. How do I actually know? Well, that's where we need PubSub Manager, right? So I'm going to open a separate instance here. What's the easiest way? Probably just go there.
Right-click, duplicate. That's right. Oh, it's Firefox. I don't know if Firefox goes through the Chrome.
Yeah. Keep your Chrome wizardry to yourself. All right. So how do I know if I've got any clients connected? Unsurprisingly, client connections. There we go. And you can see here, I've got these nice dials, and it's telling me I've got 2 connections. Now, we're talking a native connection. So which one of these options do I go to? It's going to be Solace clients, right? There we go. And as if by magic, we can tell we're actually connected. There's some really useful information here. Just by going over this, I can see that, for instance, I'm on, I'm on Firefox on OS X. Yep. Really nice.
What's that other one there?
This one, hash client.
Yeah.
Ooh, now we're talking Solace magic. Okay, in Solace,
I always just tell people to ignore them. That's just saying anything that starts with hash.
But actually, I'm going to come back to this if we have time. In Solace, if you've got clients or anything like that with a hash in front of it, and this applies to topics too, which is something I'll come back to.
Usernames, anything.
Yeah. If it's got hash in front of it, it's generally something to do. It's a system thing. It's in this case, it's a system-generated client with a system-generated client username. Sometimes you don't have to worry about them, like I wouldn't worry about this one. Sometimes we do need to know about them, and we might talk about that in a minute. But what could we do?
Let's just ignore it. Yeah.
Sorry?
I said let's just ignore it for now. So
yeah, just don't worry about hash client. All right. So what can we tell about our particular connected consumer? We've got some stuff here. Let's have a look in properties. What can we find out there? There's some really useful stuff. How long has it been connected? What's its address? And some really funky stuff about what's the user. We've got some things about API versions, what platform we're running on. Really useful stuff that helps you debug what's going on. So am I connected with the client I think I am? Am I using the API that I think I am? That's all relevant here. Furthermore, there's more stuff to show. We've got all of this here. We'll come back to subscriptions later on, but we've got our statistics tab here. That's really funky because it gives us some rate information and it gives us some message count information. Yeah. Whoa, what's going on? I haven't sent anything. I'm a subscriber. Why have I got messages here? Well, these are client control messages. So these are things like I've logged on. Here's my API version as an example. So you can see exactly what's going on with the client.
Keep alives. Those are keep alives. That's what that is.
Yeah, exactly, right. And some other keep alives, by the way, for people, that's just heart beating between the broker and the API saying, I'm alive. Are you alive? Yes, I am. Good.
Yeah. Sorry.
Other useful things you might want to look at when you're looking at this statistics tab are these statistics here. Message discards. The broker has thrown away some messages. Why? They're in here. Not going to go into the details of that now because it's a bit off topic, but these are really useful. These should help you understand why perhaps you're not receiving a message that you expect to. Okay.
Yep. These stats are on all the time, right? Every client that's connected into Solace, all of these stats, all of these message counters, rate counters, discards, all of this is being counted all the time. So it really helps in kind of debugging. You come along at some point and kind of want to investigate that particular client or whatever. You know, you don't have to enable debug or anything for this to.
Yeah, it's on by default. That's a good point. Classic use case for some of these statistics is, oh crap, my application didn't get any messages. There must be a problem with Solace. You go in here and you find there's no messages flowing, and you look at the network statistics. Hey, there's a network problem. You go to the network team. What do the network team always say, Aaron?
It's always our problem.
There's never a problem with the network when you talk to the network team.
Networks look fine. Everything looks fine on the network.
I've looked on the switch. There's no problem. And then you come back with some Solace statistics that say we had a TCP retransmission, and they go, oh yeah, there's a problem with the network.
They look a little harder. 55 minutes left. So
whoa, let's get going. I think we're going. We're good. We're good. I think we'll be fine. Right.
Hold on. Before that, Mr. or Ms. Cool Dev Ninja says these stats don't really care about the API we use from the application side, right?
Correct. Yeah.
These stats. I mean, some stats are Solace specific, I think, but the vast majority of these will all be for all of the APIs. So, for example, you know, the control messages. There is a detailed view of that, and you can see which specific control messages are being sent between the API and the broker. Open APIs, MQTT, AMQP don't have the same specific types of control messages. Sometimes they do, like add a subscription. but sometimes they don't. So I think generally, in terms of like message counts, rates, probably some of the discards, those will be available across all the different APIs. So mostly it shouldn't care. Most of the stuff it shouldn't care, I think. So.
Yep.
I've never run into anything where it's like kind of weird that, oh, I wish we were tracking this on this API. So.
It does raise a good point, actually, that I hadn't considered. There are statistics available in the Solace native APIs, and there's some calls you can make to grab those statistics, but we're not going to talk about that today. They are available.
Time. Session stats. Yep, good call.
Okay, right. Hey, guess what? We've done it. We've got that bit done. Right. Okay, we want to connect to the broker.
Wait, what bit have we got done? We got a subscriber running, and you've looked at the connection, right? That's what we've done?
Yep, that's what we've done. We've verified. People can now verify that they've got a connection, so they can check that their code works right.
Good, yep.
So we now want to get the code connected to the broker. We want to start talking about sessions. So let's do that. Quick one on API initialization. If you are in C, you have to call this thing called Sol Client Initialize. And that just really well, one of the things it does is some memory management, for example. So if I go to, whoops, that was a mistake.
Java's a lot easier for a lot of reasons, you know. That's why.
Yep. But if I go to Hello World Sub as an example, some stuff we'll talk about in a minute. Do some argument parsing, and then here we initialize the API and we pass in log levels. I'm not going to talk about logging, except to say one thing that often causes some slight delays in dealing with support issues is we want to know what's going on in the API, and we'll say, can you turn logging up on the API? And people go, yeah, and they put trace on their application, but not at the API level, and we're no further along. So yeah, just bear that in mind. You want to be able to pass the right log levels to the API. Okay, good. Right. We've initialized the API and we've talked about logging. Do you see what I did there? All right. Let's move on.
Java, don't really need to do anything. It's easy peasy.
Default is log4j for Java. Well, use whatever you want, obviously. All right. Sessions. Let's have a session. All right. What is a session? A session is essentially, if you think about when you're connecting to the broker, you've got to go over the network. You're probably going to be using a TCP socket, depending on your operating system. And there's a load of stuff that you have to do there. Part of the whole point of using somebody else's API is you wrap all that up. And what we do in Solace is we wrap that all up in something called a session. It's an abstraction of the connection to the broker, and it deals with things like the TCP socket and some of the threading concerns around dealing with a TCP socket. Okay, so how do we set up our session? Because obviously we need to tell the session where to go, you know, which host, and what's my username and that kind of stuff. We have these things called session properties. I'm talking about Java here. This applies to most of the other languages. So for JavaScript, for instance, we create this properties object here, and then we've got these enumerations that enable us to fill it out. So let's have a look at our code. Here we go. Look at that. It's almost identical. So here what we're doing is we're taking command line arguments, obviously, and feeding it into this JCSMP property called host. Okay. Interesting point very quickly. Let's do some actual coding. In these samples, we tend to, oh, no, it is actually there. We tend to ignore the whole idea of the password, right? But in Solace Cloud, you will always have a password because authentication is on. So you need to use this password flag here. Okay.
That was the fix that I made, actually. Haha.
I wish you hadn't, because I was like, oh, I could do that online. But
no, it's optional. Passwords are optional. So
yep. Cool. All right. How do we do that in C? Okay, so we've got initialize. What we're going to do is use this session properties array here. So there we go. Const char star. Okay. Right. I have carefully skipped around some code, but we're going to talk about it in the code lab here. threading. Obviously, when we've got any kind of socket, we have to be quite careful about threading.
Mm-hmm.
Now, in Java, and Aaron's probably got a better grip on this than I have, you're actually provided with 3 threads by default. You've got the reactor thread, the notify thread, and the application thread. Did I get that right?
More or less. Yeah, that's what it. Yeah.
More or less. I like that. Damning with faint praise.
No. There's a few other weird ones, but that's pretty much
right.
exactly it. Those are the 2 main ones plus the application one. Yeah.
Yep. Okay. So notify thread is for sending stuff to the socket. The reactor thread is for reading stuff off the socket. And then you've got the application thread. The point being is that there are API provided queues between the reactor and the notifier, so that your application thread is always decoupled from the socket threads. There is an option to turn off that separate reactor thread, unless you're a bit of a ninja. You don't want to do that. And you'll probably understand why when I start talking about the C threading mechanism.
Yeah.
So in Java, you've got these native queues that are sitting there that are buffering you from the socket. Anything else I should say there, Aaron?
No, you pretty much don't have to worry about it. Java is made to be super easy, right? So like you almost don't need to mention it for like until you get deeper into the code. But C is a little bit more important, right? C, right.
If you are a performance or latency ninja, there's some things we need to talk about. We need to talk about how we're going to read from the socket and how we're going to give that to the application thread. What socket reads and writes to, what thread reads and writes from the socket? That's the context thread. And in C, we have to explicitly configure it. You can provide your own context thread. Most of the time, vast majority of the times, we can use the API provided context thread. And that's what this snippet of code does here. It uses this initializer, and we use this default with create thread. Okay, so we use context create to create the context. So looking in the code, that's the bits I carefully kind of skipped over earlier. Here we go. So client context create. Let's use all the defaults. It makes life a lot easier.
Yep. Okay. Just for getting started, yeah, might as well. Don't mess around with this stuff. So,
I mean, honestly, unless you've got some super kind of outlandish requirements, usually the default context is fine. I have had to override it on a couple of occasions, but there people were doing things like running gateways that were then interfacing to Solace, for instance, and they needed lots and lots of open file handles, as an example.
Okay, hold on. Before we move on, and we should move on because we're at 45 minutes to go. Cool Dev Ninja asks, is the threading model the same with other native APIs, JavaScript, Python, ?
Yes.
Python, we don't have one yet, so we can't say for sure, but it will be similar to the C model. I have a pretty strong suspicion. JavaScript, because it runs in a browser, it's typically single-threaded. There's only kind of one execution thread available to the JavaScript app. So I don't know JavaScript that well. I've hacked together a bunch of demos, but it's always kind of just Googling random things off Stack Overflow to make things work. But to my understanding and knowledge, it's all non-blocking. So basically, as soon as you run a method or you return from a call, you hand that thread back to the browser to carry on and do the next event that is thrown into the application or into the browser. So a little bit different in JavaScript in that you don't really have control of threads, whereas in Java and C, you're much more able to control access to them and what you want to do on them. So.
Yep. As with all of these things, there is a downside to that level of control. Let me just brush that very quickly. When you get a message in C, the message callback is in the context thread.
Yeah.
Remember, the context thread is dealing with the socket. Yeah. So if you say, I don't know, open a database, and that blocks, you are no longer reading from the network, and there's a good chance you might end up deadlocking. Now, there's a load of smarts in the API these days. We've gradually added conditions to this, which will get you out of danger. But basically, you might end up in a deadlock situation. People don't like code that deadlocks. Please do not block the context thread. If you need to do some processing, create a queue, put it in a data structure, have your application thread deal with it. A classic example, of this where you can cause problems. You read a request reply message, you read the request message in the callback, you format a reply message in the callback, and you send it in the callback. And it works most of the time until there's a network problem and your socket fills up and we deadlock. Don't like it, please don't do it.
Much easier to avoid in Java because you got that extra layer of threads. But yeah, but as a general rule, don't do anything blocking or long running at all in the callback. Just that's a good rule of thumb. So yeah. Right.
Let's create the session.
Yeah. Do it.
Yep. So first point to note, when I create this session, what am I doing? I'm creating an API object. The same is true for things like topics. Okay. Oh, that's a confusing one. I've created a topic. No,
it's a Java object or whatever.
Yeah, you've created an API object. Okay, so we create the object, and then generally we have to do something on it. In this case, session connect. Right? Bit different in C. You just call sol client session create. You pass in the properties and some pointers. So you're going to pass in the context pointer and the session pointer, and this thing called session func info, which is just an API provided set of information. We'll talk about that in a minute.
It's kind of similar, right? You got your properties, you got your context is already done in Java, but yeah, it's similar calls. It's just specific to the language.
And this is kind of the point, right? There's some language specifics, but the ideas, session properties, sessions, create the sessions, they're broadly similar across all the APIs, right?
Yep.
Okay. Job done. We can connect to the broker. So I've got the, Was there a question?
No. I'm just saying, let's go. I like it.
All right. Mini code sample. Let's have a look at that. Here's one I created earlier. Tom simple sample. Gotta love it.
Nice.
Let's close this. Here we are. Oh, I should have deleted those unnecessary imports. But apart from that, this is my baby. This is all I need to get connected. Read some command line arguments.
That is a tight loop. While true, no delay.
Yeah. Yeah. Let's spin that thread hard.
Exactly. Your CPU is going to be thinking.
I'm not warm enough. Let's kick out some heat from my laptop. So this is kind of your simplest code, right? You're going to create your session properties and fill them out. You're going to create your session object. You're going to connect your session, and away you go.
Yep. Then you're online.
Let's do it.
Let's do it and watch pop.
Probably connected. Aaron, how are we going to find out whether we're actually connected?
Oh, well, you already showed us, right? Go to the old PubSub Plus Manager there and take a
that's what we want. Let's have a look. So let's go back to client connections. Oh, we got 3.
Is that the right one? Is that the cloud?
Yep.
No, that's your local host. Okay,
that's a local host. Yep, and I connected to local host. How many have we got? We got 3. Oh, am I thrashing my CPU there?
Thinking about it. Oh, yeah.
Here we go. Right. Again, useful stuff. My laptop, my process ID. Damn useful for debug. This hash number here is some identifiers of the context and session. Don't worry about it. You can have multiple ones. If you ever do that, you can identify it through that string. And we could go in and look at more details. We could look at statistics as we did before. We can look at subscriptions. Oh, no, we don't have any. We do have one. We're going to talk about that in a minute.
But default one. Yep.
We have nothing particularly useful, but then again, that's exactly what we expected, right? Good. Session created. We are connected. We now know how to connect to a Solace Broker using native APIs. Life is good. All right, good. What are we going to want to do next? I imagine we're probably going to want to listen to a message. And here's where we need to introduce some things. I talked earlier about this reactor pattern. That's this idea of doing things asynchronously. How do we do that? Well, what we do is we specify some code that we want to execute when something happens, and that's a callback.
Callback.
Right? Yeah. We have lots of lovely callbacks in Solace.
In Solace, it's lots of non-blocking code.
Yeah, we got callbacks up the yin-yang. So the first one you want to be aware of is this thing called a session event callback. So session is a connection. Connections get interrupted. They get disconnected. Very good instance of this is with Solace's amazing HA, right, where you've got an active and a standby node. If the active fails, will fail over to the standby node. The APIs will handle all of that reconnection for you. But what happens if you're trying to do something while you're reconnecting? Well, your session event callbacks will tell you what's going on. They'll say, oh, I'm trying to reconnect. Oh, and I've successfully reconnected. Maybe you want to start continuing on with a particular process. How do we do that? Well, we want this session event handler interface you can implement, and you've got some methods in there that you want to override to do whatever logic you want to do when you get a particular event. In C, it's just a matter of passing in a function pointer. And that's it.
I usually use it to just like kind of turn GUIs like green or yellow during reconnections. That's what I usually use it for, or red if there's a problem, right? So
yeah. And there's
use it for lots of stuff.
So there's some other
signaling.
things.
It's how the API signals to the app, right?
Yep. Another good one is don't do anything until my session's connected, right?
Yeah.
So you don't have to block in connect. Just let me run through some stuff in C briefly. CCSMP intro samples.
I haven't done C in so long. This is a good refresher, Tom. Thanks.
Yeah. Oh, I'm not sure you want right. So here's our event callback. It doesn't really do anything, but here's the
doesn't do anything. That's lame.
That's fine. That's fine. I would rather you had just the empty event callback. How do we pass it into the session? Well, we've got these context func info. It's a default initializer. We've got session func info. And what we're going to do is we're going to populate session func info with our event callback.
Oh, okay.
Yeah. So just a function pointer into this structure here. Oh, look, message receive callback. That's rather nice. That's how we're going to pass in our message receive callback. Okay. So if we go up here, here's our message receive callback. Nice function prototype there. And
dumps. Yeah.
Yep. What are we going to do? We're going to print something where we should probably log it, but never mind. And we're going to use this lovely function here called Sol Client Message Dump, which a bit like SDK Perf is your friend because it essentially decodes the message and gives you a nice textual output for it. Okay.
Useful up until you get above about 5 messages a second. Then it gets a little bit, your I/O starts to slow things down. So yeah.
Yeah, I once was helping a guy who was doing Sol Client Message Dump and like typing it through a whole load of Linux kind of search commands to find the event he was to find the message he was interested in.
Oh my gosh, that's one way to do it, I guess. Yeah.
Wow. All right.
Grab this long stream for. Wow. Yeah, sure.
Exactly. Yeah, he really got the whole Linux kind of small, simple pipes kind of things. Okay, Solace samples. Let's have a look at topic-subscriber.java, where we can see some of the same stuff. Notice
one thing I think I want to mention. You did talk about it a little bit earlier on. There is another Java API. There's quite a few Java APIs, but the Java RTO, the real-time optimized. You are showing C, you are showing Java here. The Java RTO is essentially the C API that's been JNI wrapped. Yep. And so, the APIs look quite different. So that if you start to play around with the Java real-time one, the JRTO one, it feels very C-like. It feels very procedural, and it's not your typical object-oriented Java API. So, but it was built specifically because the C API can operate with no garbage collection. So this is what Tom was saying in terms of performance. But 99% of apps, you don't need that level of performance. So it's like you just stick with the regular this Java API called JCSMP, and soon to be superseded by the second gen of it. You don't need to go down the RTO JNI path. Unless you're like really trying to do, microseconds of latency we're talking about here. Right?
Yeah, it's typically low and predictable latency, right?
Yeah.
Yep.
So,
okay, we got to crack on.
Yeah, let's do it.
How do we do it in Java?
Here, so.
Yeah. How do we do it in Java? Right, we've got a new API concept here, and that's this message consumer object here.
We're doing the callbacks now, message callbacks?
Yeah, we've just done the receive callback in C. This is how you do it in Java. What you do is you do this get message consumer on your session, right? And you pass in this XML message listener class. What this sample does for brevity is does it as an anonymous class, but obviously you could implement your own class based on that. When you want to kind of fill it out a bit more. Inside that, you've got some methods to override. On receive is a good one. On exception, there's been a problem. You dropped out of on receive, for example. And yeah, in comes your message there. Okay. Callbacks for everything. It's good. Yeah. Excellent. All
this
right.
way, like your consumer application, like it's kind of an important event-driven concept right? It's like you're not polling the broker looking for give me the next message or blocking calls, waiting, give me the next batch of messages. It is register this callback, and the API will run this method whenever it gets a message for you. So your app is just, it does whatever it wants. And it only gets pinged when an event happens, when a message or an event comes in on the broker that is meant for that particular consumer, right? So it's you're not polling, you're not trying to find out what's happening. It just messages are fed to the application by the API on demand, essentially, as they're needed. So.
And that's a good example of why the whole threading model idea is so important, right? Because it's all driven from these, for instance, in the Java case, from the reactor thread, putting something on a queue, and then your application getting stuff off that queue fed by the API underneath for you, right?
Yeah.
Okay. All right. Quick extra bit of work. We're not going to cover that. We're running out of time. Right, receiving messages. How does our application know in a PubSub case, in a PubSub messaging pattern, how does it know which messages it needs to get? How do we deal with that with the broker? We want a subscription, right? Now, if you're used to JMS, prepare to be a little confused. Right. Okay, we need to create a subscription. What do we subscribe to? We subscribe to a topic. Right. Key point in Solace, and I always talk about this, is that a topic in Solace is completely dynamic. And actually, in many ways, it's just it's a property of a message, an address on a message. It is not really an artifact on the broker. You don't send something to a topic on the broker. You annotate an event with a topic.
It's too bad because even our own API documentation calls it a destination, and I always say that's such a legacy way of thinking about topics, right? It's a destination. It's a thing to send it to, like a mailbox. Yeah, you're exactly right. Topics are just descriptions of the payload. Yeah, it's a metadata essentially of that.
There are various things around how this works. It's so important because really, in terms of event-driven architectures, this is where the power is. Because it's completely dynamic, you don't have to do anything admin on the broker. And if you set up your topic structure, remember, we're not creating artifacts here, so it's all about the structure, the topic taxonomy. If you do it correctly, it'll out-survive you in your employment probably. And people will still be hooking into your topic taxonomy in years and years time, right? Super important. We've just released actually some topic taxonomy best practices, and we've also got our 6+1 event-driven architectures adoption methodology, and that talks all about topic taxonomies in there. Super important. Purposes of this code lab here, remember, we're just creating a topic object in the API when we create a topic. That's this here. This is not something.
Time check. We have around 30 minutes left.
Yeah. I'm getting faster and faster. I'm speaking faster and faster. Thanks to me. But it's good. We're in part B. We're nearly there. Right. Okay. So we are creating a topic object in the API, just like we did with the session. That's just a session object. Here we go. Right. And here's where we use the factory here. So we want a singleton that's just going to return us this object, and we just feed in the string we want. Another important thing about Solace topics, they're hierarchical, and they have wildcards. I was going to talk a bit more detail about that. We're going to have to skip over that now, but we've created this topic object. What do we do now? Well, we need to actually send it to the broker, and we do that on the session, and we call that subscription, right? In C, we just call the function directly, and we can just pass in the string. We don't actually have to create an object.
So one thing is that, even while we say topics are not created on the broker, that they're part of the message, subscriptions are. These are broker, well, not configurations, but these are injected into the broker that the broker maintains, right? So we create this topic. Now, when you're sending messages, the topic is part of the message. But when you're a subscriber, we use a topic for a subscription. A subscription is something that the broker does kind of track, right? So a little bit different kind of concept there, I guess, eh?
Yep. So here we go. We've created the topic.
Yep.
What would happen, Aaron, if we tried to add subscription here after we created the topic?
Right away? Well, you're not connected, so you're having
exactly.
Yeah.
Because when we do this create subscription thing, we're actually sending a control message up to the broker. Good. Excellent. So here's where we do that down here. We add subscription and our topic. So let's do that thing. Ooh, great. We're connected. How do we validate that? Oh, let's not go there. We know how to do that now, right?
Yeah, but you can see the subscription. Hit a refresh on
exactly. Right. So let's go back to our client connections.
Yeah.
Now, interesting point there, Aaron. If I were to hit refresh on that particular client connection, it'd be nothing, right?
Yeah. People get confused by this because every connection is going to have the PIDs, the process ID is in there. Your client name is going to change. Unless you are manually setting it to always be the same thing, you're going to have to kind of go back and kind of see your new name, right? So
you can override the client name here. But okay.
But client names have to be unique, right? So you get into trouble if you start hard coding it and then you want to run two versions of your app. So careful on that.
Yep. Okay. So we're connected. We know we're connected. Yes. Subscriptions. Here's my subscription, right? And the point being is that this is the thing that exists on the broker, the subscription, not the topic, the subscription. Okay. We talked earlier about hash client. Here's another hash P2P. What's this subscription I didn't ask for? This used to be called the P2P inbox. Hash P2P stands for peer-to-peer. This is a unique subscription that every client is automatically assigned to by the broker, and it's a way of sending messages to only this particular client. When's that particularly useful? Well, let's say you're doing request reply messaging. What will happen is if you call the API function that sends a request message, it will automatically annotate that message with this automatically generated reply to topic here, so that your responding application can automatically send it back to this client and only this client. You can override that, but that's just illustrating what this particular topic is for. Good.
Inbox. It's your specific you only topic.
Yep. Okay. All right. So how are we going to send it a message? Try me. Let's connect.
Connect to publisher.
Yep. Now, publish. Important point here. Let's use a useful topic.
Change it to because we're not using wildcards on the subscription, the topic has to match exactly, right? It has to be the exact same string, uppercase, lowercase, same string, and whatnot.
Yep. Okay, we'll talk about delivery modes in a minute when we talk about sending messages, but here we're just using the default try me. We're going to publish a message. And with good luck and a following wind, we've received it in our subscribing application. Oh, yes. That's annoying how it's done that. Excuse me a second. Right, here we go. Point from earlier. Ignore the red. That's just because I haven't set up log4j properly. Here we go. So if we look at our on received, we've got, message received and message dump. And in C, you saw that sole client message dump. Here we've called .dump on the message object. And you can see here we've got lots of useful information. What was it sent to? And we've got a sender ID, we've got a timestamp, and we got the binary attachment, which is the payload of the message. If we go back here, the message content, right? Oops, not that one, that one. Okay, good. There is something I haven't talked about. Something that's important to talk about when we're receiving messages. If you see here, we've got this message object here. What's the lifetime of that message? Well, in this particular case, it's going to be essentially it's for the duration of this callback. Now, that's super important in C. If we look at message receive callback here, we've got these message pointers. So these message pointers are, we call them message buffers.
Yeah.
And they're API provided globs of memory that you shouldn't poke into. As it says there, sole client opaque message pointer. But it's the API manages this memory for you, these message buffers for you. So when we get a message, we'll grab a buffer off the buffer pool and stick the message information in there. Why is that important? Well, it all comes to this return code here. So client callback OK. What that tells the API is that when I exit from receive callback, I am done with this memory, so it will be automatically freed. Or not freed, rather it will be returned to the buffer pool.
Yeah.
Now, if I don't want to do that, I need to return sole client take message. I can't remember the exact enumeration, but what that says is, hey, Mr. API, do not return this buffer to the pool, and then you have to explicitly call something called sole client message free.
Yeah. This is like, which you probably do in almost any kind of more than hello world type C messages, C applications, right? Because you're not going to be processing in the callback. We already talked about, don't process in the callback. So you're going to hand it off to another thread somehow in a ring buffer or a linked list or something. And you're going to have to say, yeah, don't blow away that, don't kill this message. We need it for later. So yeah.
General best practice there.
Yep. Good one.
Good.
Yep. All right.
Right.
We're at 37. And don't kill yourself to finish at exactly noon. We'll or whatever. We'll if we have to for a few minutes. That's fine. So
no, we're good.
But I think we're almost there. We
are almost there. Yeah. So we've done this. We've sent a message from Try Me and we've received it in our application. Life is good.
Right. And you've just shown JavaScript to Java, right?
That's a good point.
Try Me tabs in the browser. I mean, people don't quite get it, but like those Try Me applications are actually embedded JavaScript applications that are running in the browser there, in the code, and it's a WebSocket connection through the internet. Well, I guess in Tom's case, it's all just local on his laptop, right? But but the publisher and the subscriber apps that are there are both two separate WebSocket connections into your broker.
Yep. And this is, when you start talking to people about kind of digital transformation use cases, this is super, super useful, right? Because you can interface your client applications, your customer applications into your, your event-driven architecture.
Yeah.
So we've got customers where they're generating things like betting odds or FX prices in their core infrastructure, and then to send those prices in real time to consumers on their mobile phones. Well, they don't have to do any distribution mechanism or anything like that. They just send them over Solace WebSockets. And because we do this zero bridging, zero translation kind of
no adapters, no plugins. It's just
Yep. Dead simple. Really powerful.
Hold on. We're in a pause. Cool Dev Ninja. Is the Try Me tab on the JavaScript side using native Solace API, or is it an example of a non-native application publisher communicating with a native subscriber? So these two specifically here.
So these are, in fact, the easiest way of doing that is to rather than, that's the wrong one. Excuse me.
Yeah.
Where is it? Is it in there? Oh, I've got lost.
Done it.
Yeah, I've got lost. It's up here. No, it isn't. It's over here. Why don't we have a look? Where is my client? Show me my client.
Yeah.
Oh, look, Try Me.
Try Me Sub, Try Me Pub. Yeah.
Yep. So it's WebSockets, which is obviously not a native, it's not a Solace wireline, but the actual kind of message event format is actually in SMF. So it is actually a native API. It's our WebSocket JavaScript API.
Click on it and go into the. It should say that in the details, right, or the properties, I think.
Yeah.
What the version is and everything. So there you go. Software version, user. Oh, yeah. I guess it doesn't say specifically as JavaScript API, but yeah.
No, it doesn't. Yes, it does. Look, JavaScript API.
Yep.
Yep.
Cool.
Cool.
There is, I mean, like there's an MQTT JavaScript kind of testing tool. If you just Google Eclipse Paho JavaScript utility, you'll find a little kind of similar web page, a little login that uses MQTT. You would essentially point it to localhost on a different port, and it would be able to connect just the same way that this little WebSocket application using Solace API is doing as well. So there are options out there for that.
I would love to do that right now, except that I haven't exposed the MQTT port.
Yeah.
Excuse me, in Docker. So
we'll do that for another time. I'm going to let the cat out. I'll be right back. Hold on. But keep going.
Okay, cool. While Aaron's letting the cat out, let's continue. We are, whoops, let's close that one down. We have sent a message from TryMe to our sample application. Good. We need to send messages. What we're going to do is send them from our application, and we're going to receive them in TryMe to start with. Okay. So in Java and most of the other APIs, just like you had to create a message consumer, we create a message producer, which is just an object that enables you to send things. In C, we don't have to do that because we're just going to call a function to do it. So without further ado, let's look at our code. So we want topic publisher.java. Let's kill that off. Let's maximize that. Okay, so we create our session. We connect our session. We're going to create our topic object. And hey, look, this looks nice and similar, doesn't it? We're going to create our XML message producer. Again, we've used an anonymous class to deal with that. And what this is here is, guess what? It's a callback. And it's a callback that says, what do we do with some events that can occur when we send a message? So obviously one of them is an error, right? Maybe the socket's full or something like that. But there's another case here. In Solace, we like to handle just about every single messaging pattern you can think of. One of those is request reply. If we send a request, we expect to reply, and it can come back through our response received method here, right? Good. Okay. Now, we need a message to send. And I've already kind of talked a little bit about this whole idea of message memory handling. So in Java, what we're going to do is we're going to essentially grab an object. Now, Java has this idea of types of message. So you can have text messages. You can have bytes messages, which is kind of a binary blob. Obviously, in text message, we're expecting it to be strings. You can also have string messages, which is Solace has its own, they're called SDTs. So that's Solace data types. So they are architecture independent data types that you can send around. So you can send an int that you could say send from ARM on a mobile phone to your Intel architecture, for instance. Okay, that's good. So, yep, we grab our message object. We're going to fill out some payload here, hello world, and we just call set text because this is a text message to set the payload of that message. And then we just call send on the producer, and we're going to pass in to send the topic that we're going to send it to. Remember again that this topic here is just an API object. This topic does not exist on the broker. It just exists on this message, this event that we're sending. Good stuff. All right, let's have a look at C because there's some important differences there. So CCSMP intro examples. Hello world pub. Good. Okay, so we've got our message receive callback, our event callback. Good, we're being good people. We've filled out our session, connected our session. Right, we need to do memory management in C. So what do? We call message alloc. Okay, so we're going to allocate a buffer that we're going to populate with our message to be sent. Okay. In C, we need to explicitly set this delivery mode. So if you remember back at our Try Me tab, you've got these different delivery modes here. So what are these? Essentially, in Solace, we have 2 delivery modes. We've got direct, which is kind of a fire and forget message mode. So I'm going to send it to the broker. I don't particularly care if the broker gets it or even if my consumers get it, because there's probably another one coming along quickly after it. The other delivery mode is persistent or guaranteed or assured, as we call it in Solace. And that's where we definitely want to make sure that the broker gets it. There's a contract. I'm going to send this message to you, and I want you, Mr. Broker, to tell me when you've got it. You're going to send me an acknowledgement. We don't have time, especially now as we've got basically less than a quarter of an hour left. We don't have time to talk about this today. That's for another session where we can talk about this whole kind of guaranteed message sending. But just for today, we're going to use this delivery mode direct. Okay. In C, rather than a topic object, we have this destination data structure. So client destination T. Let's go back there where we say this is a topic and here's the stream, right? So
we get it off the command line. Oh.
Yeah.
Okay. That's
different. All right. Okay. Yeah. Yep. Now, some best practices we need to talk about. Always do this. Always send it to a topic. And there's a very good reason for that. You may think, well, hang on a minute, I've got a one-to-one queuing use case here. I want to put this message on the queue. Well, you can do that in Solace, but you can send it to a topic. And how do you do that? You use this idea of topic to queue mapping, which is where you create a queue. And on that queue on the broker, you say, I want you, Mr. Q, to subscribe to a topic. Always do that. Why? Well, imagine you've got this point-to-point case. You're sending a message from a producer to a consumer. And then later, along comes Mr. Data Lake, who needs to receive that message. Do I have to change my producer to send the message twice? We don't want to send the message twice. That's horrible. So what do? Well, the thing is if you've sent it to a topic, you can just create another queue and have that queue subscribe to the same topic. That gives you so much agility and decoupling. And it's one of the real bases of Solace's kind of event-driven vision. Yep,
it's essentially, you know, being future forward friendly, you know, with your architecture. You can just, you know, if everybody works with topics, you want to be able to extend it in the future, adding additional consumers for different analytics or fraud or data lakes or anything, you know, dashboards. You just subscribe it to the same feed. You just subscribe, and now you get it like data for free, right? It's almost like you just consume it off on the side. So always publish on topics. That's a great number one mantra for Solace.
Yep.
Publish on topics. My shirt should say.
Yep. Oh, I know. We nearly forgot something and you didn't remind me. How do I decide what my topic taxonomy should be? Are there any tools to help me? Oh boy, do we have some tools to help you. So if you go to, whoops, that's not it. Remember earlier when I was looking at the
back to the console.
Yeah. We have this thing called Event Portal. And that is the space where you can design, define, catalog, and discover the topics that you're using in your architecture. Don't have time to really run through this in any details today, but just to show you very, very quickly, here are the events we've got in this particular Acme Rideshare application domain. If you've seen any of our demos of this, you'll understand it. But if I look at my Ride Accepted event, there's my topic, right? Fully hierarchical, it's got dynamic fields in it, but this is the place where you want to go when you're starting to think about how do I create my topic hierarchy, my topic structure, how do I find out what my other applications are sending to.
There's also that blog and documentation now in the docs on our friend Ken's topic best practices, which is, as you start to think about this, your taxonomy, designing it, that's a really good reference to go and check out best practices on how to build your topic hierarchy.
Absolutely. And that best practice, it goes in with our 6+1 adopting event-driven architectures. It's
link
in
down
there.
there. Check out the link down below. Tamimi's throwing it up. So excellent.
Good man, Tamimi.
Job. That is quality reading material that will keep you riveted and up all night. It's really, really interesting and important.
Yeah, it's really important. All right. Good.
All right. So
excellent. Where are we? Let's go back to our code lab. How are we getting on? We need to send a message. So we've got our producer. We've got our message objects. Oh, message objects. Important point. Oh, good. It's here. Right. An unfortunate feature of these samples that Aaron especially is trying to deal with is this problem here. So what we've done is we've created a session, we've allocated our message, we filled out our message, we send a message, we free our message, and we quit, which is kind of fair enough, but it's missing out on some important points. A session is an expensive object. There's a whole load of system calls to bring up a TCP socket. Please don't send a message, close the session, start another session, nothing bad will happen apart from you just won't run very well. It just won't run very fast. You're wasting a lot of resources. Keep the session open for as long as you need to be connected to the broker.
That's right.
That's the most important one. That's the most. That's another best practice for you. Another best practice, slightly less important, but not important nonetheless, is that, as you'd expect, memory allocation is expensive. It's not as expensive as session creation, but it's expensive nonetheless. So rather than constantly create message buffers with our message alloc up here, sending it, getting rid of it, and starting again, what you should really do is allocate it once, fill it out, send it, and then do this reset idea. So solid message reset or message.reset. What that does is basically say, okay, I'm finished with this buffer. I'm going to kind of scrub over all the important bits so that you're ready to refill it in again. And that will give you much better performance because you're not constantly calling out to memory allocation or garbage collection. Indeed. Okay, delivery modes, destinations. Yeah, remember the topic.
And all that. Yeah.
Yep, remember the topic is that's just in the API. It's just an address on the message when we're sending. That's it. Message context. We've done that. Oh, that's it. We just hit send.
Yeah.
Isn't that lovely? Oh, let's do that thing. All right. I happen to have noticed that we've got some disconnections because we've got some timeouts. So let's just hit timeout again. How do we know we got those timeouts, Aaron? What API feature did we use?
Oh, I'm sure they've subscribed. Well, not subscribed. Sorry, they've implemented the callbacks in the JavaScript API because our JavaScript API has these session callbacks as well. Connecting, reconnecting, reconnected, disconnected, connection lost. All of these, right? So. Subscription success ad is a callback, message received as a callback. It's all callbacks, all of it.
Yep, it's all callbacks. All right, we want to send a message from our code. Let's just go back to here to check we know what we're doing. We want to, oh no, it's up at the end. It's up at the start. We want to send from our sample to try me. So what we're going to have to do is subscribe. And subscription is like a control message we send up to the broker. Now, the samples use tutorial/topic like this. I'm not going to do that. Why am I not going to do that? I'm going to show you the power of topic wildcards. We can use a single level wildcard, or we can use a global from here on in any number of topic levels. Wildcards, start and greater than. So if I do that, you can see I've got my subscribed topics down there. I can go in and check my subscription.
You want to zoom this in one click or two?
Sorry.
Maybe? Yeah, that's all right.
There we go. Look at my subscriptions, and there's my tutorial greater than.
Multi-level wildcard.
Yeah, super cool. Another very important feature of our kind of event-driven kind of vision there. Alrighty, let's publish a message. Let's do topic publisher. There we go. Message sent.
Sent a message.
Let's hope so.
Did it?
Well, hey, look at that, baby.
Ta-da.
Ta-da!
How do we
Nice.
know that that's the same hello world? That payload looks the same as the other one. Maybe
All right.
change the payload or something, make it more unique there, Tomo.
Okie dokie.
This is just to verify we're not receiving an old message or something.
Good
Which you
idea.
can't put direct because you're offline, but that looks better. That's pretty unique.
There we go.
Change the topic too. Let's publish on topic 2 or something at the top.
That's a good idea.
Why not? You got a wild card, right? So it should work.
Oops. Some more levels.
That's long. Okay.
Oh, well, how long a topic could we make? We can, turns out you can take pretty long topics. They can be up to 250 UDF-8 characters. So you've got a lot of flexibility, huge amount of flexibility. And in fact, part of our topic best practices say, use as many levels of hierarchy as makes sense. Use more rather than less, because you never know, later on, you might need to pick out on a finer level of detail.
That's right. Because it's through the wildcards, it's through the levels that we kind of have that routing, filtering capability that the broker is so good at, right? If you have very coarse topics, then your client API has to receive the whole flow and throw away things, at the client, after it's gone across the network, after the API has received it. Whereas having a well-defined topic hierarchy and you can use wildcards and all that cool stuff means you can have the broker do that heavy work for you, and you, the client, only get what you want to see or are allowed to see, right? So.
Yep.
Right.
Cool. Okay. I'm going to hit clear messages.
Clear that. Yeah.
Clear those messages. That's clear stats, right? I've got no messages. Got nothing. I got nothing.
Yeah.
So
your subscription's still there though, so that's okay.
Yep. Good. So let's send.
Run it again. Boom.
Well, hey,
yes. Ta-da.
This is a sample message. Cool.
Excellent.
Do you know what? Just to finish off, just for the pièce de la résistance.
Oh, yeah.
Why don't we start up our subscriber, and we can show publish subscribe. I'm going to start up the subscriber. We're away. I'm going to change the topic back because that topic subscriber's got a hard-coded topic into it, which is not ideal. We really want dynamic topics.
You got an extra S there, Tom. Get rid of that S.
Yes, indeed. Thank you very much.
Yep.
All right. Clear stats again. All right. So we've got nothing. Let's do publish. Boom. What's happened? So this is our publisher, topic publisher, and we've got the message in our subscriber. But as an added bonus, we've got another message in our try me. So actually what we've ended up with is this picture here, right down at the bottom. We've got publish subscribe, right? We've sent a message once and we've received it twice, a copy of the same message in our native Java application here and in our native JavaScript application here. Quite neat, shows you doing publish subscribe, but also receiving across different languages, different APIs. Had we had time to show it, we could have connected an MQTT client, for instance, there and shown receiving it in MQTT2, all natively without any configuration on the broker here. The only configuration is the subscription that I've injected in the API.
Well, you had the usernames. That was configuration. You have to have a username to connect with. I guess that's about it, really.
That's it.
And an IP address. So.
Yep, that's it. And that, folks, is largely it. We're coming up against the end of our scheduled time.
That's perfect timing. Look at that.
Yeah, man. How's that?
Mimi's back. Hey, yo.
Yeah.
On the dot. Do you see that? It is 11:59.
It's exactly 11:59. Hats off to you both. That was fantastic. That was great. Great timing.
It was paced too. I don't know if you noticed, but it went all the same speed the entire
Yes.
It was definitely all the same speed all the way through. Definitely, Aaron. Yeah.
There. Oh man, no, this is great. Thanks very much for going over Solace native APIs and for authoring that code lab, which is live on our codelabs.solace.dev. So anyone who's watching, you could go check it out. So thank you very much for that, Tom. So basically, if I wanted to break down API, the Solace APIs to basic concepts, would you say that it involves initializing, session creation, callback, and then message handling, basically.
Yeah, that's a good way of explaining it. In fact, in the wrap up here, I've kind of brought that out. So we run out of time to cover up things like closing sessions and things, but that's obviously a nice thing to do. But yeah, initialize the API, set up your logging, create session properties, and connect the session. Create the session and connect it. Stick in your subscriptions. Start your message consumer. You probably want to start your message producer. Create some messages and publish them. Populate them and then send them. That's what you want to do. Best practices. Don't send a message, close the session, open the session up, keep your session open, reuse your message buffers. Yep. Yeah. Always send to a topic, other one too. Yep.
Okay, perfect. And as you mentioned as well, there is definitely way more other features and functionalities in APIs, such as logging, queue creation. You mentioned guaranteed messages, so that
replay. Caching,
request reply, correlation.
Yeah, there's a lot more. Where would someone be able to go check out these other features in the Solace APIs for the Solace?
Yeah, sure. So obviously the first place I would go to is docs.solace.com to read a bit about the feature and what check this exactly what you want to do. Secondly, the samples, as I kind of mentioned earlier. So let's hold on a minute. Let's de-maximize that one. If you go into kind of the feature part of the samples, so that's either with the download, and here you can see a lot of features that we're covering, or in Solace samples itself, you can see you've got the features thing there. That's quite small. Unfortunately, it's difficult to maximize, but here we've got some of those extra features. So Aaron mentioned replay, and there's a message replay sample. So that shows how we can, hit. Oh, look, we've got a callback that's dealing with events that are generated as a result of replay.
Right, and these are all kind of like found in the samples that they could download. So either in the GitHub repo, Solace samples GitHub repo, or Solace.com downloads, and any API comes with a pre-downloaded list of functionalities, basically, and features.
Yeah, exactly. Yep.
Perfect. Awesome. I think we've covered it all. So we went over our code lab that you put together, which is great. Just a reminder to anyone who is watching us and still on, we have a poll that you could fill in. If you didn't fill in, you could go ahead and fill it out. There's the link down there, and there is the QR code. And this is it. Yes. So again, I think this is all what we had today. So thank you everyone who's watching. Aaron, Tom, any last remarks, last things to talk about?
Not really. Go download the APIs, start using them, have some fun with them. I mean, it's one of the things I noticed when I first started Solace is actually messing around with these APIs is a lot of fun because there's so much you can do so quickly, so easily.
Right. Perfect.
Come join us on Solace Community. Ask us questions there. It's where we're going to lurk. And it's probably the easiest way to come and find Q&A and kind of see some of the other stuff we're doing. I post things on there all the time, blogs and whatnot. So demos. So come up, Solace Community. It's a good spot to hang out and check it out.
I mentioned earlier, so we have the Solace Community and we have our Solace events, where we're going to be posting a list of any upcoming events that's coming up. So next week.
What's the next event, Tamimi? Let's have a look.
This is the next developer workshop event, which is a design to code using the portal plus async API code generator. So for those who watch us before on our YouTube channel, we're aggregating a list of developer events. So you can see that we had that was the wrong YouTube link. So async API. So on our YouTube channel, we have a list of videos that we posted, so you can check them out as well under playlists, developer virtual events. So we had a live coding session with Fran from Async API, and what we're going to be doing on our next workshop or next event is a workshop where we go over a code lab, and it's very, very interactive. So feel free to go check it out there, join the community. like, share, subscribe, follow us, on Twitter, all that.
All those good things, yeah.
Good things.
Hit
And
the bell for the notifications, right? That's another good one.
Hit the bell for notifications. Exactly, that one too. Yeah, that's pretty much it for now. So thank you everyone for watching. And Mark is saying thanks all. So thanks, Mark. And yeah, so that's pretty much it. Thank you everyone, and have a good day.
Thanks everyone.
Bye guys. Thanks.
Bye.
See you later.
All right.